Alright, the next type we're going to learn is single displacement. So single displacement, just like the double, where you're going to have a compound and then a single thing is going to swap out. So if this thing tends to form a positive charge, it's going to swap places with the positive part of this compound. And if this thing tends to form a negative charge, it's going to replace the negative part of the compound. Typically in your chemistry classes you use an activity series because you're going to have more active metals are better at giving off their electrons, so they're going to end up being as part of the aqueous compound. Less active metals like gold are going to be reduced, and they're going to stay as whole solids and separate. But in the AP Chem test, if it's a single displacement, it happens. So a lot of these things, you're not going to have no reaction. It happens. So figure out if it's going to form, if the single thing forms positive and negative charge, swap it appropriately. You have to know to be able to do these correctly. Again, you're going to have to know your polyatomic ions sometimes. You're going to have to know common charges that metals form. And that's about it. So I have a bar of strontium metal, so that's Sr. It forms a positive charge, so it's going to be the first part of this compound when it swaps. It's immersed in copper 2 nitrate, so plus CuNO3 2. Alright, so what that's going to make is it's going to make strontium nitrate, and the copper is going to be by itself. SrNO3 2 and copper. Alright, so I have to leave the net ionic equation, which means I should write all these things as ions. So this is actually Cu as a 2+. My reaction's balanced, so we're good. Plus 2 nitrates, NO3 1- goes to Sr2+, plus 2 NO3 1-. Alright, so I can see that the nitrate didn't change. So my net ionic equation is going to have the nitrates taken out. So it's really going to be strontium as a solid plus copper 2 ion reacts to form strontium 2+ plus solid copper. And that's my net ionic equation. The next one, I have a strip of zinc. It's placed in a solution of nickel 2 nitrate. This time I'm going to go ahead and say Ni2+. The nitrate's always soluble, so it's not going to do anything. It's going to be a spectator. We can include it if we want, or I could just say, yeah, we'll include it. Because I think it might be easier for us to see it. So we're going to say nickel 2 nitrate, NO3 with a 1-. Oops, 1-. So there's 2 nitrates. Okay, so I know that zinc forms a 2+. That's just something we memorized. We know silver is always a 1+. Zinc forms a 2+ in compounds. So there we have some aqueous zinc nitrate, and we're leaving some solid nickel behind. Okay, so now I want to cross out any spectators. So this really was nickel 2+. So zinc plus nickel 2+ plus 2 nitrates makes zinc 2+ plus nickel plus 2 nitrates. The nitrates are going to be spectator ions, so I leave them out of my net ionic equation. Then next, I have a piece of copper wire, Cu, is placed in a solution of silver nitrate. So silver always forms a 1+, nitrate 1-. And then I know my products are going to be, copper tends to form a 2+, so CuNO3 2. And you just get that from, maybe when you think of copper, the most common solution you think of is copper 2 sulfate. So maybe just having seen that that's how it's usually existing. So now I actually have to balance this reaction. So I've got 2 nitrates here, I'm going to need 2, and I'm going to need 2. And then when I go ahead and write just the net ionic equation, I can see I had 2 aqueous nitrates here, 2 aqueous nitrates here. I'm going to cross out the nitrates. So I've got solid copper plus 2 silver 1+ ions makes copper 2+ plus 2 silver atoms. Alright, and then for the last one, I have a small piece of calcium metal, so calcium is added to hot distilled water. So I'm going to have H2O. Okay, So calcium tends to form a positive charge, so it's going to replace the hydrogen if anything in this. So I can see it is a redox. Whenever you have an element present, it's going to be a redox. So I know I'm going to be making calcium. If it's 2+, it's going to be attracted to the OH of the water hydroxide. I'm going to be 2 hydroxides. And the other product is going to be hydrogen gas, because if this went from a 0 charge to a 2+, it was oxidized. Something had to be reduced. Something had to gain electrons. H+ can gain electrons to become neutral. O2- can't gain any electrons, so they're going to go to the H+. And if I reduce H+, I turn it into hydrogen gas. Okay, so then I'm going to want to balance this. If I'm going to make 2 hydroxides, I'm going to need 2 waters to do that. And that's going to leave 2 H+. Those 2 H+ are going to gain the electrons from this guy to become H2. Okay, so I've got 1 calcium, 4 hydrogens, 2 4 hydrogens, 2 oxygens. So it's good. And this one doesn't have any spectator ions. So that's good. That's single displacement.